Hey there, this is going to be a short video on how to calculate some molar masses. So what we're going to do first here is we're going to look at an example of a compound such as magnesium nitrate. And what we're going to do is calculate the molar mass of it, right? So the first thing we have to know is that the molar mass of magnesium is a certain value based on the periodic table, right? So here's one of the components of this compound. The second thing we need to know is the molar mass of the nitrogen in that compound. So here's the information from the periodic table for that element in this compound. And then last but not least is oxygen's contribution. So what we're going to do here is we are going to take the 24.31 for the magnesium, and we're going to add that. Sorry, my pen wasn't working there. 24.31 grams, which is the mass of 1 mole, right? Remember this from the previous video, that's the mass of 1 mole of magnesium. Then we're going to add that to, now remember in this compound right here we have 2 polyatomic ions which are nitrate because each of those is a 1 minus, right? And remember that's why we need a 2 to balance with the magnesium that's a 2 plus, right? So in this right here, we have a total of 2 nitrogens. So we're going to add the molar mass of the magnesium to 2 times the molar mass of the nitrogen, which according to the periodic table is 14.01 grams, right? So again, the 14.01 factors into this number right here. And then last but not least, we're going to deal with the 16, which is the molar mass of oxygen. But in this compound, we actually have 6 oxygens, so it's going to be 6 times 16.00. And if we take out our calculator and do this addition, we should get a final overall answer of 148.33 grams, which is the molar mass, or simply the mass of 1 mole. Alright, so that's how you do it for something like a compound that is complex and has some parentheses and multiple instances of atoms. The next thing we're going to look at here is what you would do if you had an equation. So here's an example of a balanced equation, and we're going to take this equation and we're going to deal with it in terms of molar masses. So just to separate out the two kinds of problems that we have here. So what we know is that this element right here in this compound, in this equation, has a molar mass of 28.02. Right? We know that because of the information that we had up here in this previous problem that told us that nitrogen had a mass of 14.01. So remember, because it's N2, I'm going to take 2 of those. The second thing we know is that hydrogen from the periodic table has a mass of 1.01. I'm just going to move hydrogen down to here, right? And I'll go ahead and maybe duplicate that nitrogen and bring it down here, right? So those are the 2 things that we're using to calculate masses in this bottom question right here, right? So because hydrogen has a mass of 1.01, we're going to deal with only the way it is written as a substance. We're not going to be dealing with the coefficient, right? So this is 2 hydrogens, so it's 2.02. and that's the mass of H2, molar mass of H2. And then what I have right here for NH3 is one of the nitrogens, and we have 3 of the hydrogens. So if we get out the calculator and do that, we end up with an answer of 17.04. And that's grams. So very important to understand that whenever we are calculating molar masses, that we would always just use the information from the periodic table. We would not use the coefficients in the chemical equation, right? We do not use the individual coefficients in the chemical equation, because really each of these that we have calculated here is the mass of 1 mole. And so 17.04 molar mass of ammonia, 2.02 molar mass of hydrogen, and 28.04 molar mass of nitrogen. Okay, that's it. Just a quick little video on calculating molar masses. Hope that helped.